Hi everyone, so let's do this question next. Same tree. So given the roots of two binary trees, write a function to check if they are the same root or not. Two binary trees are considered the same if they are. Wow, this question is so easy. I just need to check, right, if it is same or not. So it means I can just start from the root and then just check if left it's same, right it's same. Yeah, I can do that. And the nodes have the same value. Yeah, so I can just start from the root and then check the left subtree, check the right subtree. Yeah, so it will be the same tree if its root is same, and then its left subtree is same and right subtree is same. So if value is not equal, then return false immediately, or if it is equal, then mm, and then I can check if tree one's left is also same, you know. Yeah, so first of all I just for every node I just check if that node is equal, or if that if that tree is equal, then I would check if its left subtree and left subtree are equal and its right subtree and right subtree are equal, right? And when if the value is not equal, then I return false, or if so 2's left and 2's left, they are both null, right? So in that case I just return true. In this case I should just return true because both are equal. Yeah, that's it, I think. So in the beginning what I did was so this is a recursive function, and I check, I just pass to this function this function takes two trees and returns if the root has same value and if left subtree and right subtree are equal. That's what this does. So here we are checking if value is equal, and here we are checking if its left subtree are equal and right subtree are equal, right? Because two trees are equal if its root is equal and its left subtree and right subtree is equal. So, and for every tree we do the same, right? And the best case is if its left subtree and right subtree both are null, then it means that is the base case. That means we have hit the base, we have hit the lowest root, lowest leaf where there is no left subtree and there is no right subtree. So at that point we can just return equal or true at that point. So from top we will just go down, just check value and just call back again and again and again, and then when it hits the lowest leaf, that will return true for us, and return true. Yeah, so what I mean is, here if this is the case, then it will just 2 4 5 6 7. Okay, so from this root only, from this root if we are passing, then this root will we call this function, and then for its left subtree also we call the same function, because this is a new subtree again and this is new subtree again. We call the same function, this new subtree again, this is new subtree again, and this is also new subtree again. So for this subtree now, 7, for 7 it will return true because it's left and right. Yeah, for this 7's left and right, because they are both null, right? So so this will return true, and then this will also return true. If it has the same, if these two are the same trees, this is the case, right? So for 1 we'll look at its tree, then again tree, look at its tree. Suppose if it was 6, then this will return false immediately. So yeah, so suppose in this case, if this is 4 and this is 6, then I think here for this 1 2 4, this, because 2's left subtree we are calling, because this is DFS, right? So since this is DFS, so 2's left subtree, so this will go down, and this will return true because 2's left subtree and 2's left subtree, they are equal, but 2's right subtree is not equal, right? Because this is null and this is 6. So at that case, actually we should also consider that case as well here. Suppose if some tree are, if tree 1 is not equal and tree 2, if one is there and another is not there, or if 2 is not there and tree 1 is there, then in that case that is also a case of false, so in this case, see, 4's right is null, but I mean 2's right is null, but 2's right is something 6. So in that case, it's a return false, and here null dot value will return null pointer exception. So we can just do this. If any one tree is not present, okay, this is for okay. And yeah, so in this case what happens is it will this left subtree will return true, but 4's right subtree, this will return null. So in that case, yeah, in that case this will be such a waste, isn't it? Because here only, in this label only, it should return false, but since we are doing DFS, it will look at all the nodes for the left subtree. So this will take such a long time. Yeah, because it has to check all the nodes of the tree. But I think BFS would have been better because on any label, if it doesn't match, then it would just return true immediately. Yeah. So I could just look at 1, then this label is 2, this label is 2, and this label is 4, this label doesn't match, so I could just return immediately. My LeetCode subscription just ended, so I'll subscribe again today.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve same tree. So I'm going to upload this on a Friday, so they also have tree, right? Or this node anymore. And now we have changed the problem. Now we actually have 2 trees left. We have one left subtree, right? These are the left subtrees. And we also have 2 right subtrees. So this is the right subtree of the first tree, and this is the second right subtree. So now the problem is changed. Now we're checking, are these 2 trees the exact same? And are these 2 trees the exact same? These 2 need to be equal, and continue to break this functions. The main thing to consider is the base case. So what's true in it? Same, these are both right tree is empty. Turn. If the statement did not execute, then we're going to go to the next one. So if not P is this both of these, then add one more. So if both of these 2 are executing the exact same thing, right? This is returning false and this is returning false. So we can actually condense this. I'm going to copy and paste this here. So if you can all statement does not execute are not, we write true. And I hope that was
okay. So this could also do the same as what I did, but this one, actually this is not needed because we already checked if both are not null, right? If both does not exist. If both are null, right? So here I don't have to check if this is not null or this. I can just do this only. Yeah, because if both are null, then it would go here. So if we come here, then it means that only one of them is not null. Only one of them is null. If we come to this, if this is not true, then if only one is null. So yeah, So it means, and I can just do this same condition 2 times here only. So this is a better code because true statement is one, there is one true statement and there is another false statement. Return statement is one, so the return path for true and false, this is just 1 and 1. So yeah. Value, but it is not val, right? Entry 1, entry 2, and this would be OR. Yep. Okay everyone, thank you very much